Alrighty, excellent. Good afternoon. A4 Precalculus CP. Today, what we are doing is working on proofs with trigonometric identities. I hope you're all having a fantastic day. And this is the last class of the week, so hopefully we're going to end it off on a high note. I can't imagine we wouldn't end it off on a high note since we're going to be doing proofs of trigonometric identities. I mean, what's better than that? So, a couple of reminders before we get started officially. Number one, just make sure that you fill out the attendance form on Google Classroom. I think for the most part, people have been good with that, but just like to throw that reminder out there every now and again. Number two, make sure that if you haven't done so already, everybody has their microphone muted and their webcam disabled. Of course, you can unmute your microphone at any point. If you do have a question, please don't be shy. Speak up, ask if you need some clarification, but just it should be muted if you're not participating at this time. Next thing I want to remind you of is the progress assessment. Yes, you are getting a progress assessment sent to you via email right after this class ends. It's scheduled to go out at 1:30, so you should receive it very shortly. It is our second graded progress assessment of the fourth quarter. It consists of 4 proofs using the trig identities. In my opinion, they are of escalating difficulty, meaning that problem 1 I think is the easiest and problem 4 I think is the hardest. But there are 4 problems, 4 proofs for you to complete. Just like the previous progress assessment, it will be sent to you via email. The expectation is that you take a picture of your work, attach it to the email, send it back to me. That is due by Sunday night at midnight, 11:59 p.m. technically, so that I can grade them on Monday and hopefully get the feedback to you on time. One thing I want to just make sure I mention is please make sure that if you can get the assessment completed on time, that you do get it completed on time. I know we all have brain farts once in a while. We all make mistakes. No problem. Things come up. I understand there's a lot of unpredictabilities in distance learning. But the challenge is if students don't submit the work on time. I'd like to post the answer key so I can give you feedback right away. But I can't post the answer key if I'm still waiting on submission. So it kind of just delays that process. So just in the interest of everyone, really, please try to make sure your work is submitted on time. Again, I understand we all make mistakes. Accidents happen once in a while. I get it. No problem. But just make sure that try to get in the habit of submitting work on time. So that's all I want to say about that. Next thing I want to make sure I mention that actually, yeah. Next thing I want to mention, I don't want to say that. Next thing I want to mention is just make sure that you are rewatching the lessons if you need to be. They are all recorded. They are all publicly uploaded on YouTube. The playlist to all of our video lessons for all of distance learning is linked on Google Classroom. I usually get these lessons uploaded the day of, or at least the day after we actually have them in class. So please make sure you go check that out. If you need any refreshers, if you need maybe just to see the problems done out again, maybe you just got stuck and you want to look at an example that's similar to one of the ones you're working on, absolutely, please go watch those video lessons. I think it's very valuable to have that just existing, so you can always go back as a resource and check that out, all right? Or maybe you just want to hear the sound of my voice. I don't know. I'm not going to judge. Whatever the case may be, go back and rewatch those lessons. Again, they're all there. I just hope you're taking advantage of that opportunity. All right, so that all being said, today, what I'd like to do with you is I would like to do more proofs of trigonometric identities with you. Specifically today, I have 4 proofs that I plan to do with you. I have more in case we have more time, but I do have 4 proofs that I plan to do with you. Last class, what I did with you is I pretty much selected a random assortment of proofs and just ran through a random assortment with you. Today, my selections are a little bit more intentional to specifically point out certain skills that you may want to draw attention to as you progress through these proofs, all right? I don't want to use the word types of proofs or categories of proofs because I don't think it's fair to actually split these into like, oh, this is a type 1 proof and this is a category 2 proof. That's not really accurate in saying that. But definitely different styles of questions in which you'll see different skills pop up, I think is something fair. Mr. Danzero actually found, I don't know if he typed it, I don't know if he created it, I don't want to take credit away from him. If he did create it, then that's awesome. That's even more credit to give him. But he found and shared with me, and I'm definitely going to share it with you, a very useful set of typed notes with examples all done out, explanations provided, and actually I can even show you. I can show you right now. Take a look. You should be able to see it on your screens now. Take a look at this. You've got examples all typed up, explanations over here step by step. You have a little bit of a description over here, some general strategies provided, and then 8 more examples going all the way down to the bottom, all typed out, done for you, step by step. I think this is awesome. I'm like, wow, how awesome is that? So that resource is definitely something I'm going to be providing for you at the end of class today. I'll make sure I upload that on Classroom as well. They're just great illuminating examples that you can refer to. So I am going to do the 4 examples that are specifically highlighted on that document with you today. Hopefully it'll be helpful for you to hear me try to explain it as we're going, and then afterwards take that knowledge and see if you can look at the actual instructions typed up and still follow along with the logic. Whew, that was a long-winded introduction, but now I think it's time to actually go ahead and tackle some problems. Ready? Let's do it. All right, let's do some more proofs with trigonometric identities. Okay. Here we go. More proofs with trigonometric identities. Let's start with this one. Can you prove that the cotangent of x plus 1 is the same as the cosecant of x times the cosine of x plus the sine of x? Okay, that's the first problem that we're faced with. Can you prove that the cotangent of x plus 1 is the same as the cosecant of x times cosine of x plus sine of x? Now, typically with a proof, what you want to do is you want to start with one side of the equation and manipulate that one side of the equation to look like the other side of the equation. So the side that you generally want to start with is the one that has more going on with it. It's the one that lends itself to have more stuff to do. If you look at this problem, on the left side, yes, you could change cotangent to cosine over sine. Maybe you could find a common denominator and then combine them together. But outside of that, there really wouldn't be much else that you can do going forward. You'd kind of run out of things to do, right? However, if we start on the left side, if we start on the right side, there's definitely a lot more going on there. So I would elect to start on the right-hand side. So my goal is going to be to manipulate this right side of the equation to make it look like the left side of the equation. So what I can start with is maybe a little distributing. How about distribute that cosecant? That'll make your right side of the equation look like this. Cosecant of x times cosine of x plus cosecant of x times sine of x. Okay, cosecant of x times cosine plus cosecant times sine. It's just a little distributing. Now we can change cosecant using our reciprocal identities. We can make this 1 over the sine of x times the cosine of x. How about plus cosecant again, 1 over the sine of x times the sine of x. Oh, well, this is awfully convenient for us right here. 1 over the sine times the sine. The sines cancel out. We're just left with this lingering 1 here. Here now I get cosine of x over sine of x plus 1, which if you're looking at your goal, you should be like, ooh, we're right there. Cosine of x over sine of x, that's cotangent. So we can rewrite that now as cotangent of x plus 1, which is now equal to the left-hand side of my equation, and therefore we've proven what we need to prove. Make sure you include your little proof signature. Okie doke. So again, I kind of like proofs. Actually, no, not kind of. I very much like proofs, but I think you should kind of like proofs because unlike regular simplification problems where you're just kind of simplifying, you're not really sure where you're going. You just kind of go until you can't go anymore. With these problems, I like that it just gives you a goal. You're working towards making this look like this. So you know when you're done. You know that you're done with your problem when you've succeeded in making this side of the equation look like that. Okie doke? All right, let's take a look at another one. Okay. So a good skill pointed out in that first problem is the fact that you can distribute certain terms, and changing all these terms to sine and cosine really helps you see which terms can cancel out and simplify a little easier. This second problem exemplifies splitting a fraction apart and working with a split apart fraction. So check out this one. We have the tangent of theta minus the cotangent of theta divided by sine of theta times cosine of theta. And we want to prove that that's equal to the secant squared of theta minus the cosecant squared of theta. Okay? So we want to prove that that's the case. Okay? Just like before, there's a lot more going on the left side. The right side, it would be tough to see how you can progress with that to make it look like this. Typically when you have a fraction, it's easier to say, how can I simplify this down to make it look like that? So let's start on the left-hand side. Okay? Again, if you started working on the right and you found that you just reached an impasse, you weren't sure of where to go, that's okay. Like, just try maybe from the left next time and say, well, let's back up and let's see if we can actually do it the other way around instead. One way is usually way easier than the other way. So now that I have this, let's start on the left-hand side. I can split apart this fraction. If I have tangent of theta minus cotangent of theta all over sine times cosine, we could split this up to be tangent over sine times cosine minus cotangent over sine times cosine. So we can make it look like this. The left-hand side of the equation can look like tangent of theta divided by sine theta times cosine theta minus cotangent of theta over sine of theta times cosine of theta. Right? Now what I can do is I can express everything in terms of sine and cosine. So I can change tangent to now be sine over cosine. So I have sine over cosine divided by this sine of theta times cosine of theta minus cotangent is cosine over sine. So cosine theta over sine theta divided by sine theta cosine theta. Okay. How do we divide now a fraction by another expression? Well, you might remember it's a little easier to visualize this if you write this instead as this fraction times 1 over sine of theta cosine theta. It's a little easier to visualize what's going on. So I'm going to change this now to be written as sine of theta over cosine theta times 1 over sine theta cosine theta. Right? Because that's the same as just dividing everything by that term. It's like saying if you take something and divide by 2, it's the same as taking that thing and multiplying by 1/2. It's the same exact idea, right? I think it's just a little more convenient to write it out that way because it's clearer to see which terms are going to cancel out when you actually do the division. Okay? So here, notice I'm going to get sine theta over sine theta is going to go away. I'm going to get in that first term 1 over cosine theta times cosine theta is cosine squared of theta. Minus. I now have cosines cancel out over here. Cosine theta over cosine theta goes away. I got 1 over sine theta times sine theta, so 1 over sine squared of theta. And hopefully the transition from like this step to this step is where the wheels start to turn in your head and you're like, ooh, look at my goal. We're almost there. We're getting there. We're really close. Now what do we need to do? Let's just use our reciprocal identity. Say 1 over cosine theta is the same as secant squared of theta. And 1 over sine squared of theta is the same as cosecant squared of theta, which is now equal to the right-hand side of the equation. And thus our proof is complete. Any questions, comments, concerns, complaints, suggestions, or inquiries about that? Okay, we're feeling fantastic. I take your silence as no questions, Mr. Giorgio. Everything is fantastic and I'm feeling great. All right, that's great. That's great. If you do have a question, though, please don't be shy. Please ask. All right, so third type of proof that I want to show you, or third style of proof that I'd like to show you is sneaky. It has a sneaky little trick in it, okay? The main takeaway of problem number 2 was showing how you can split apart a fraction and why it's beneficial to do so, because then you could simplify individual components. This one's a sneaky little math trick, and I want to make sure I show and explain it to you, okay? It's sneaky. Typically, I don't like sneaky stuff in math. I think it's usually unfair to ask sneaky things, because it's not really assessing what you're kind of designed to be able to know, but this one I think is important. Okay. We want to prove in this particular example that the cosine of x divided by 1 minus sine of x is equal to 1 plus the sine of x over cosine of x. All right, we want to try to prove that that's true. Now, what's tricky in this problem is the fact that no matter which side you start on, whether you start on the left side or you start on the right side, there really isn't much that you can do. Yes, you could split this fraction up. Actually, my first idea when I did this problem blind is I was like, we could split this up to 1 over cosine, that's secant, plus sine over cosine, that's tangent. Now I have secant plus tangent, but that doesn't get me anywhere near this, right? It doesn't really work. So what I actually want to do is I notice over here that suppose I'm starting on the right-hand side, and you could start on the left and work this way, but for our sake, I will start on the right-hand side. It would be a pretty equivalent process if you start with the left-hand side and work to make this look like this. But for our purposes, I want to showcase starting on the right-hand side and making this look like this. So what you should notice here is you want to get, this is your goal, you want to get 1 minus the sine of x. You want to get a factor of that in this denominator over here, right? You want to get a factor of 1 minus the sine of x in the denominator. Unfortunately, there doesn't really seem to be a way to make that happen with the tools we're given over on the right-hand side of the equation. So what we can do is, again, a little sneaky math trick. In order to get 1 minus the sine of x in the denominator of this fraction, I can multiply this fraction by 1 minus sine of x divided by 1 minus sine of x. Take a look. I can say we can take this fraction on the right side and multiply by 1 minus the sine of x over 1 minus the sine of x. Okay? It's sneaky because 1 minus the sine of x over 1 minus the sine of x, that's 1, right? And multiplying anything by 1 won't actually change its value. So that's why we're allowed to do that. Your first instinct for a problem like this may be to say, hey, can I cross multiply? Can I multiply this times this and this times this? The answer to that is not really, because with a proof, the structure is that you don't want to change one of the sides of the equation. You want to leave this the same, and you only want to work with this. This kind of accomplishes the same thing as cross multiplying. If you notice, if we cross multiplied, quote unquote, we would be multiplying 1 minus sine of x times 1 plus sine of x, and that is kind of what happens here. All right? But it's a little sneaky math trick to say, I need a factor of 1 minus the sine of x in this denominator. Like, that's my goal. I need that to happen. And I can't see any way to make that happen. So let's just force it in there. Let's just say multiply by 1 minus sine of x over 1 minus sine of x. That will now get a factor of 1 minus sine of x in the denominator. And maybe we can do some manipulation to get that cosine out of there. Take a look at what happens now. What happens now after I multiply this together is I now have in the numerator a factor of 1 plus sine of x times a factor of 1 minus sine of x, divided by in the denominator the cosine of x times 1 minus sine of x. Note that you wouldn't want to just cancel these out, because that would, like, if you just cross them out, that just gets you back to where you started. What you could do instead, though, is you can distribute the numerator. In the numerator, you could do 1 times 1 is 1, a little first, outer, inner, last, the distributive property, no aluminum here, minus sine of x times 1 plus sine of x times negative sine of x minus sine squared of x, all divided by cosine of x times 1 minus sine of x. Okay, I'll leave the denominator the same for now. Now that we did that, take a look at what happens. Negative sign, positive sign goes away. You're left with now 1 minus the sine squared of x divided by cosine of x times 1 minus sine of x. And 1 minus sine squared of x, you should be like, ooh, wave your hands all in the air. Woo, wow, look at that. 1 minus sine squared, that's our favorite Pythagorean identity, the very first line that you see there. Sine squared plus cosine squared is equal to 1. So you could say 1 minus sine squared is the same as cosine squared. Now we're getting somewhere. Over cosine of x times 1 minus sine of x. One of the cosines will now cancel out with that cosine. We're left with cosine of x in the numerator over 1 minus sine of x in the denominator, which is exactly equal to the left-hand side. So my proof is complete. Okay. Again, a sneaky math trick of multiplying the same thing divided by itself, because that really is just multiplying by 1, but it's a way for us to force that factor to be in the denominator. The reason I determined that I could do that, or I should do that rather, is because that's what's in my goal. I need to get that factor in my answer eventually. Let's just make it happen. Any questions, comments about that? I know that one's a little confusing. No questions? Check back in with the Meet here. Where's the Google Meet? See my desktop a little bit there? Nothing? Nothing. All right. We're going to keep rolling then. We're going to keep rolling. We got one more problem to do. How about this? Let's get a brand new sheet of paper. Here we go. Last problem I want to show you today really emphasizes the skill of being able to find a least common denominator and stick fractions together rather than pull them apart. Almost like a problem, actually not almost, exactly like a problem that you may have seen in Algebra 2, just now with sines and cosines instead of x's. So let's try a problem like this. Let's see if we can, last example of the day, prove that 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta is equal to 2 times the secant squared of theta. Okay? A lot more going on that left side, so that's why I would definitely elect to see if I can manipulate the left-hand side to look like the right-hand side. What I can do here is I'd like to be able to stick these fractions together. But before I can stick these fractions together, we need to find a least common denominator, right? Think back to Algebra 2. In Algebra 2, you probably did problems. I know it was a while ago, it was last year. But you did problems where you had 1 over something like x plus 5 plus 1 over x minus 3. And you had to find a least common denominator between the two of them so you could stick the fractions together. It's a very similar process here. The least common denominator is both of these factors put together. I need the denominator to be 1 minus sine of x times 1 plus sine of theta rather times 1 plus sine of theta. That's my least common denominator. This, remember, is one singular factor. You can't split this up and say, oh, we have one already. These are glued together. So we have a factor of 1 minus sine of theta and a factor of 1 plus sine of theta. In order to make this denominator look like this, what's missing? Well, what's missing is this, 1 plus the sine of theta. So I'm going to take this fraction and multiply the top and bottom by 1 plus sine of theta. Right? Remember, we can't just change the bottom. So I'm multiplying our first fraction times that. And our second fraction, what's missing in order to make this least common denominator, or in order to get this least common denominator, it's 1 minus the sine of theta. So I'm going to take my fraction of 1 plus sine of theta, which is already there, and now multiply it by 1 minus sine of theta over 1 minus sine of theta. And that will get us our least common denominator. Okay? I tried to explain it in a way very similar to how I would explain it in Algebra 2, just with signs now instead of x's, but it's the same idea where I'd say this is my least common denominator. What piece is missing to get from this denominator to this denominator? It's this. What piece is missing to get from this second denominator to this? It's this. So that's why we multiply by each one. Now, when I actually do that, I'm going to get the first fraction is going to come out to be 1 plus the sine of theta, because 1 plus sine of theta times 1 doesn't change. In the denominator now, I have these two factors of 1 plus sine of theta times 1 minus sine of theta. The second fraction now, again, in the numerator, 1 times that quantity won't change it. We got 1 minus the sine of theta. Oh, geez, that was not a straight line. In the denominator, I have 1 plus sine of theta times 1 minus sine of theta. Ooh, sorry, that was so sloppy. Jeepers. Okay. Now, since these have the same denominator, I can go ahead and stick them together. We could rewrite this now as 1 plus the sine of theta plus 1 minus the sine of theta. Just sticking them both together. Now all over 1 plus sine of theta times 1 minus sine of theta. Okay? Last but most certainly, well, actually not really last. Last in this sort of combining the fraction process, we can now simplify the numerators, if you notice. Sine of theta minus sine of theta goes away, and so I'm left with 2 in the numerator. And you should be thinking to yourself, yes, this is a good thing, because look, our goal has a 2 in it. That 2 needed to come up somehow. So the fact that you see this 2 show up in the numerator, you're like, ooh, this is good. This is part of our goal. All right, fantastic. Now let's see if we can work with the denominator to somehow progress towards this. I can distribute these factors in the denominator, first, outer, inner, last. We're going to get 1 times 1, which is 1. 1 times negative sine of theta is minus sine of theta. Sine of theta times 1 plus sine theta. Sine theta times minus sine theta is minus sine squared of theta. Okay. Again, we see some canceling, which is great. Minus negative sine and positive sine go away. I'm left with 2 divided by 1 minus the sine squared of theta. Once again, that's our best friend Pythagorean identity that we've seen before. 1 minus sine squared of theta we can write as cosine squared of theta. And take a look at our goal. Take a look at this. We need it to look like this. It currently looks like this. Remember that the cosine, we can use the reciprocal identity, express that as 1 over the secant. How do we divide by a fraction? You multiply it by the reciprocal. And that's just going to turn into 2 secant squared of theta. Look at that. That's the same as the right-hand side. And so our proof is complete. Pretty cool. Definitely a lot of steps. But it's important to be able to find a least common denominator, just like you did in Algebra 2. In fact, that's why in Algebra 2 there's a big emphasis placed on that, because you need to do it in this idea in pre-calc and even going forward in calculus. It's definitely a skill that you're going to need to know how to do. Find a least common denominator, change all the denominators to match it, combine the fractions, simplify from there. Easier said than done. I understand that. Definitely is going to take a lot of practice. And that's really the best way to understand how to get good at these types of things. You might be thinking to yourself, how the heck am I supposed to figure out that I need a least common denominator? How am I supposed to figure out that, oh, at the end I have to change cosine to 1 over secant? That is really going to come with practice. I think it is very much to your benefit to do the practice problems that I've provided if you haven't done so already. This document that I just showed you has a ton of practice problems on it. I'm going to go ahead and post it on Google Classroom as well. It's a great resource for you. Just practice makes perfect. That's really all I can say. Again, you will be getting that progress assessment sent to you via email. I don't want to take up too much more of your time because we are at the end here. So I will just say for one last time, does anybody have any questions, comments, or concerns for me before we call it a day? Where's the actual meet? No questions? We're feeling fine? Everybody's doing fantastic? Alrighty, I'll take that as yes, we are doing fantastic. Excellent. Well, if you do have any questions or concerns, please do not hesitate to reach out. You can just send me a Hangouts message if you want and just say like, hey, Mr. Giorgio, do you mind if we jump on the Google Meet really fast? I'm not going anywhere. I'm staying within these 4 walls, so it goes right to my phone. I can definitely do that for you. If I can't do that, I'll tell you that, hey, can we schedule a time for such and such? But do not hesitate to reach out. I am here for you if you need me. But other than that, your progress assessment should be in your inbox now. I do hope you have a fantastic weekend, and I will see you on Tuesday. Enjoy. Thank you again, and have a fantastic day.
Have a nice day, Mr. Giorgio.
See you later, Sophia.
Have a great weekend, Mr. Giorgio.
Nick, adios.